Okay, so let's solve the ODE. Let's take the binomial expression x minus 1 times y prime is equal to 1 over x. Um, so first, let me go ahead and bring divide both sides by x minus 1. So I'll bring it over to the other side. And I'll write this as y prime equals 1 over x times x minus 1. So if I break up y prime, and I'm not breaking it up, I guess. I'll write it in Leibniz notation, and then multiply both sides by dx. I'll get dy equals, I guess I can write this as dx over x times x minus 1. And of course, in the separable technique, the next step is to integrate. So on the left-hand side, it's pretty simple. Again, it's just going to be y from the first fundamental theorem of calculus. And on the right-hand side, again, I wanted to give another integration technique. So for this one, we'll need a partial fraction decomposition. Okay, so we'll need to decompose the 1 over x times x minus 1 into the two parts, or the two fractions that probably added to get the 1 over x times x minus 1. So I'll break this up into a over x plus b over x minus 1, where a and b are just constants. I mean, x in both of these factors in the denominator, they're linear terms, so I'll just put a constant above. If they were quadratic, I'd put a linear factor above, but for now I'll just have the constants a and b. So in a partial fraction decomposition, again, we're trying to find the constants a and b such that a over x plus b over x minus 1, when added, gives 1 over x times x minus 1. So the first thing I want to do is, let's go ahead and multiply both sides of this equation by x times the binomial x minus 1. Okay, and so I'll get 1 is equal to a, the x's cancel, times x minus 1, plus b, the x minus 1's cancel, times x. And if I distribute the a, I get ax minus a plus bx, and then if I factor out an x, I'll get a plus b times x, and then I just have the constant minus a. So now if I want to compare the left hand side to the right hand side, it should be clear that I have no linear term on the left hand side, so the a plus b must equal 0. And then the constant term on the left hand side, of course, is 1, which says that the minus a should equal to 1. Okay, so in order for the left hand side to equal to the right hand side, the linear term on the left hand side should equal to the linear term on the right hand side, and the constant term on the left hand side should equal to the constant term on the right hand side. Well, this one's actually pretty easy because I readily get a. So a is just equal to negative 1. And if a is negative 1, then negative 1 plus what is equal to 0 says that b must equal to 1. So now I know the fractions that made up the a over x plus b over x minus 1 in order to get the 1 over x, x minus 1. So let's go ahead and integrate the dy. So we're kind of going back here now, and I'll just get my function y of x. And here, instead of integrating 1 over x, x minus 1 dx, and I know that I'm going to integrate a over x plus b over x minus 1. It's the same as me integrating, let's say, a over x dx plus the integral of b over x minus 1 dx. Okay, so I just substituted this. Well, I already know a and b, so I can write y of x and this step is not necessary, you could have already substituted in a and b, gives me the negative integral of dx over x, because a is negative 1, so I just put the negative 1 on the outside, plus b. Well, b is just 1, so I get plus the integral of 1 dx, which is just dx over x minus 1. Okay, so this actually is pretty simple, because the integral of dx over x is just the natural log of the magnitude of x, and that's important because I don't have any initial condition to tell me what region x is in. And if it's a negative region, I need to write as the natural log of the negative of x. And in here, I get plus the natural log of the magnitude of x minus 1, again, plus some arbitrary constant.